Hello everyone, I hope you're doing well today. Today we're going to learn how to determine the degree of a polynomial function either by looking at a table or a graph. Let's start off by looking at tables. So the first thing that we need to know is that we're looking at the constant finite differences. If our first difference is constant, we have a linear function. If the second is constant, it's quadratic. If the third is constant, it's cubic. If the fourth is constant, it's quartic. And if the fifth is constant, it's quintic. I know this probably doesn't make much sense at the moment, but it will make more sense after an example. Right now, please take a moment to pause this video and record this table in your notes. Now let's look at an example together. In order to use finite differences, our x values must go in a pattern. So looking at my x values, they're going up by 1 each time. Since my x values are going in a nice pattern, I can use finite differences. So I'm going to find what's known as my first difference. To find the first difference, I'm going to look at the y values. My first pair of y values are -5 and 1. So I'm going to take 1 and subtract -5 to get the difference. That gives me a difference of 6. Then I'm going to look at the 1 and the 12. If I take 12 and I subtract 1, I get a difference of 11. Then I'm going to look at the 12 and 29. 29 minus 12 gives me a difference of 17. Next, I'm going to look at the 29 and the 53. 53 minus 29 gives me a difference of 24. Finally, I'm going to look at the 85 and the 53. The difference between 85 and 53 is 32. All of these numbers are what is known as my first difference. If you notice, they're not constant because they're not the same. So I need to do this process again and start looking at my second differences. So if I start off first, looking at the 6 and the 11, the difference between 11 and 6 is 5. Next, I would look at the 17 and the 11. 17 minus 11 is 6. Then I'd look at the 17 and the 24. 24 minus 17 is 7. And finally, I would look at the 24 and the 32. 32 minus 24 is 8. These are what's known as my second differences because I've subtracted twice. Now my second differences are still not constant, so I need to do this a third time. So I'm going to start off and subtract 5 from 6, and I get a difference of 1. Then I would look at the 6 and the 7. 7 minus 6 gives me a difference of 1. And finally, I would look at the 8 and the 7. 8 minus 7 also gives me 1. These are what's known as my third differences because I've subtracted 3 times. After I've subtracted 3 times, I have the same number each time. Therefore, I go to my table of finite differences and I would figure out that I have a cubic function because my constant finite differences are the third differences. Please take a moment to pause this video and record this example in your notes. Now let's try looking at another example. Again, I look at my x's first, and they're going up by 1s. So my x's are going up in a nice pattern. I can use finite differences. Now, both these examples, the x's have gone up by 1s. It doesn't matter. They could go up by 2, 3, 4, or even it could be going down by a certain number. As long as it's going up or down by the same value, you can use finite differences. So I'm going to look at my y's and first subtract 32 from 22. And I get a difference of -10. Then I would look at my next pair and subtract 22 from 15. When I subtract 22 from 15, I get a difference of -7. Next, I would subtract 15 from 15 and get a difference of 0. And then I would subtract 15 from 24. When I do that, I get a difference of 9. And finally, I would subtract 24 from 42 to get a difference of 18. And this gives me my first differences. Now my first differences are not constant, so I need to do it again. So I would start off by subtracting negative 10 from negative 7 to get a difference of 3. Next, I would subtract negative 7 from 0 to get a difference of 7. Then I would subtract 0 from 9 to get a difference of 9. And finally, I would subtract 9 from 18 to also get a difference of 9. And these are my second differences. My second differences are not constant, so I'm going to go ahead and do this a third time. I'm going to first subtract the 3 from the 7 to get a difference of 4. Then I would subtract the 7 from the 9 to get a difference of 2. And then the 9 from 9 to get a difference of 0. And these are my third differences. Now my third differences are not constant, so I need to go ahead and do this one more time. When I subtract 4 from 2, I get a difference of 2, negative 2. When I subtract 2 from 0, I get a difference of negative 2. So here's my fourth differences. My fourth differences are constant at negative 2. Therefore, the degree of the function would be 4. Please take a moment to pause this video and record this example in your notes. We can also determine the minimum degree of a function by looking at its graph. In order to do this, we use what's known as turning points. A turning point is a point where a function goes from increasing to decreasing, or decreasing to increasing. If I look at this graph, I have a turning point right here because my function is going downwards, it's decreasing, and it turns going upwards, making it increasing. So there's one turning point. If I look here, I have a second turning point because my function is increasing and it starts going downwards and starts decreasing. And I also have a turning point right here because I'm going from decreasing to increasing. So I have a total of 3 turning points. To find the degree, I need to add 1 to the number of my turning points. So my degree would be 3 plus 1, or 4. So this function graph has is a minimum degree of 4. Please take a moment to pause this video and record this example in your notes. Let's look at one more example with turning points to determine the minimum degree of a function. Now at negative 5, it almost looks like there's a turning point because the graph kind of does a funky little curving. But there's no turning point there because our graph is increasing the entire time. It never decreases. So if I look at negative 3, I do have one turning point because it is going from increasing to decreasing. There's also a turning point at negative 1 because I go from decreasing to increasing. There's a turning point somewhere between 0 and 1, and there's also a turning point around 3.5. So I have a total of 4 turning points. If I have a total of 4 turning points, that means my minimum degree is 5 because I need to add 1 to my number of turning points. Please take a moment to pause this video, record this example in your notes, and any questions that you may have for me when we have our next Zoom meeting. See you soon.